Hello everyone. I just wanna share this problem from mechanics lecture that I have taken. This is my test 2 quiz. So I just wanna share the solution of finding the internal force of truss member using methods of joint. So this kind of truss is kind of cantilever from this left side of a truss geometry. So there is a 8 kilonewton and 10 kilonewton from the other joint. This is an external load and a 2-meter length horizontal from A to B and B to C vertical 2-meter also. So by analyzing or by um, by observing the geometry, so this is 90-degree member from this member A to C, which is perpendicular to member B to D. So the first we have to do is to draw the free body diagram. So it means that you free the body. So in substituting this is a pin support and roller support. So in pin support, there is a two unknown reaction that is resisting in the truss. So we can assume two forces reaction, and we don't know what are the direction of these forces. And for the roller support, there are only one reaction that is resisting, which is perpendicular to the plane of the support. So that is the reaction. So I will assume that RBY is upward and RBX is going to the right. And for this roller support at joint C, I will assume the direction of the force going to left. So this is reaction C, RC. Okay, so first, for using the joint method, we will find what is the value of the reaction. So we were using the equilibrium equation, which is summation of moment at any point is equal to 0, summation of moment at any point is equal to 0, summation of force horizontal is equal to 0, and summation of vertical is equal to 0. So we will find the reaction using the equilibrium equation. So first, either summation of moment at B is equal to 0 or summation of moment at Z is equal to 0. So the reaction value you will be able to compute for these three reactions is the same. So for now, we will using the summation of moment about point B. Summation of moment about point B is equal to 0. Okay, so we're here. Okay, in the sign convention we were using, so if the rotation is clockwise, our sign is negative, and if the moment rotation is counterclockwise, we will use positive sign convention. So this RC, reaction C from B, it will create a clockwise. So this is negative RC times the moment arm of 2 meter plus 10 kilonewton times, so by observing the geometry, so this is from B, this is 1 meter, and from the horizontal also 1 meter. So 10 times 1 meter. So from here, the 10 kilonewton creates counterclockwise, so positive. The same as 8 kilonewton from B, it will create positive moment, which is counterclockwise. So 8, and the moment arm is 2 meter. And this RBY and RBX is concurrent at point B, so the moment arm is cancel out, so that is equal to 0. And then using the equilibrium equation, this is equal to 0. So by solving the RC reaction, we will get 13 kilonewton. So this is positive because this term will go onto the other side, which is negative, divided by negative 2. So that's why it is positive 13. Therefore, our assumption for RC is correct, that the direction is going to the left. But if in case that this RC that we get is negative 13, our assumption is wrong. So kinda this direction, going to the right. Okay, so next, solving for RBX or RBY. So it is much easier, or either way. So RBX, we will going first. So summation of force horizontal is equal to 0. So RBX, so our sign convention we're using, if it is going to the right, this is positive, and going to the left, it is negative. So kinda using the X and Y quadrant. So sorry, It's reverse y and x. So for horizontal, which is x, going to the right, positive, and going to the left is negative. Also, in the same way, positive for up, and then negative for down. Okay, so summation of force horizontal is equal to 0. So we have only two horizontal. So the positive RBX minus RC is equal to 0. So we already get the RC, which is positive 13. So RBX minus positive 13 or 13 is equal to 0. So RBX therefore is equal to 13 kilonewton, which is positive. So this direction is going to the right, which is correct. And then the last one for RBY positive, so going upward. So sorry, this is summation of force vertical is equal to 0. So RBY is going upward, so positive. And then the external force is 8 kilonewton downward minus 10 kilonewton is equal to 0. So this is 1. If you sum it up, negative 18, and then transfer to the other side. So RBY is equal to positive 18. So which is RBY is correct in terms of direction. Okay, so now we're gonna proceed to the joint method. Okay, joint C. So we will begin at joint C. So in a joint, it's okay to begin as long as the unknown forces is available to get the internal forces. So this problem, we will start with the joint C. Joint C. Okay, we will draw the joint. This is the point joint. So this one we will considering joint C. There is a internal reaction or the reaction force, which is RC. RC value is 13 kilonewton, and there is a member BC. So we don't know if that is compression or tension. And then the other member, which is DC. So we don't know what is the correct internal force for member DC. So by analyzing this, the DC is only the member who is resisting the reaction of 13. Okay, we'll adjust this one. So by breaking the component for this DC, so we can therefore assume that DCX is going to the right. And if that's so, the DCY will going downward, and then only the BC will resist the DCY member. Okay, so This is the assumption. Anyway, if we are mistake for the assumption, the result of the forces will be negative. So using the equilibrium method, summation of force horizontal is equal to 0. So dcx positive minus 13 is equal to 0. So dcx is equal to negative 13, but dc is a component for the member dc. So we're gonna find the slope for this one, that member. So by analyzing that slope, we will get 1 square root of 2. So this slope, so 1 and then 1 meter. So that's why if you imagine this kind of triangle, so this one is 1 square root of 2. Why square root of 2? So by Pythagorean theorem, hypotenuse, so 1 squared plus 1 squared square root, so this is the hypotenuse. So hypotenuse length is square root of 2. Okay, so or 45 degree, because the base and the height is same length, so this is 45 degree. So dcx is kind of this one, so dc member times 1 all over square root of 2 is equal to 13. So therefore dc is equal to 18.385 kilonewton. Okay, that's one. And then we will go to member BC. So summation of force vertical is equal to 0. DCY negative because it's going downward, plus BC, and that is equal to 0. We have DC, which is equal to, or this DC is equal to 13 square root of 2. It's the same as 18. So negative DC, 13 square root of 2, that's the value of DC, but DCY is 1 over square root of 2. Okay, because DCY is equal to DC 1 over square root of 2, plus BC is equal to 0. So that's why BC is equal to 13. Anyway, this DC is compression because it's going toward the joint. The internal force of the member is compression, and DC is going away, which is BC going away, which is tension. Okay. Now we proceed to joint B. So this is the point of joint B. We have the reaction RBX. This one, RBX is 13, RBY external. So we have to kind of slash so that we will notice this is an reaction. So this one also reaction. So, and this BC member is tension, which is equal to 13 also. And this has member BD, which has a slope of 1 square root of 2 or 45 degree. We don't know the forces, if it is compression or tension. And AB, it's the same situation. We don't know yet the direction. So we were going to assume the AB, it's gonna be in tension. AB, sorry, it's gonna be in tension, and BD also in tension. Right. So we will break the BC force into a component. So BC Y, and then this is BC X. Okay, summation of force vertical is equal to 0. So BDY, this is BD. BDY, BDY, BDX. BDY, negative, going downward, minus BC, going downward, and then the reaction of RBY, which is equal to 18, minus plus RBY is equal to 0. So this RBY is 18, BC is 13. So we have left BDY. Negative BDY is equal to negative 5, because negative 13 plus 5, 8, and then we will cancel out the negative. So BDY is BD times 1 square root of 2 is equal to 5. Therefore, BD is in positive, so the assumption is correct, which is 7.071 kilonewton tension, because it is away from the node. That's why it is tension. And lastly, for member AB, so summation of force horizontal is equal to 0. So AB plus BDX, so it's dotted line. Also, sorry, so this is all negative because it's going to the left, and then plus 13 is equal to 0. So we can say that BDX is equal to 7.071 times 1 over square root of 2. And then 13, so negative. So if we calculate this equation, we will gonna get AB 8 kilonewton positive. So this 8 kilonewton is also tension. Right, the last joint we will considering is joint A. Joint A. This is joint B, this is joint A. So joint A here. Okay, there's a member AB here, which is 8 kilonewton tension and the external force of 8, and then member AD, which we will assume a compression AD. Slope is the same, 1 square root of 2 or 45 degree, which is theta. Okay, so we will analyze this joint A. The summation of force vertical is equal to 0. So ADY, so we will break this AD. ADY positive minus 8 is equal to 0. ADY is 1 over square root of 2 minus 8 is equal to 0. AD therefore is positive. That is 11.34 kilonewton, which is in tension. So that's it for AD. So we can check the forces if it is correct by analyzing joint D. So joint D should be 0. Okay, that's the solution for joint method. It takes 20 minutes more to watch this video, and thank you for your listening. Bye.